Hi everyone, this is Mrs. Jackson. This is Chapter 4, Section 2, Part 1. In this video, we're going to look at how to solve rational equations, and we're also going to learn about a new term called extraneous solutions. How do we solve rational equations? Actually, it's the same way we solve all equations. We use inverse operations and properties of equality. So let's take a look at a problem that you've definitely seen in Algebra 1 before. We have two ratios set equal to each other. And two ratios set equal to each other is called a proportion. We might as well write that down. And so 2 is being divided by x. If I want to undo division, I would undo division with multiplication. And I'm going to multiply the left by x, and so by properties of equality, I would need to multiply the right by x. Likewise, 7 is being divided by 8. So if I undo division with multiplication, I would have to do that on both sides. And you can see that there's an x in the numerator and x in the denominator on the left. That will reduce to 1. The 8 in the numerator and the 8 in the denominator on the right will reduce to 1. And so it appears that this 8 is just magically cross-multiplying up over this equal sign, and the x is magically multiplying up over that equal sign. And so cross-multiplication looks kind of like a trick, but it's not. Cross-multiplication is just inverse operations and properties of equality at work. But cross-multiplication certainly does speed up problem solving. So if I continue with my inverse operations and properties of equality on this simple problem, I get x equals 16/7. Try to resist the tendency to turn that into a decimal as well as a mixed fraction. Just leave it as an improper fraction. So this is a problem we would have done in Algebra 1, but what we didn't focus on then, which we know better now, is that we must exclude some domain here to make this a valid problem. And that is exclude any value of x that's going to create an undefined term. And you can see here that x cannot equal 0. Otherwise, we would have 2 over 0 in the problem. All right, so before we move on to another problem, I wanted to talk about one property of proportions. There are many, but the reciprocal property of proportions in particular is extremely convenient to use to speed up problem solving. So in this case, I have a over b. These are just placeholders. A over b equals c over d. By the letter of the law, I really should write that b cannot equal to 0 and d cannot equal to 0. So if I use my cross multiplication techniques, then I get what's called my cross products, which I can have b times c equals a times d. So these are our cross products. And if I further divide both sides by AC, and I could divide both sides by anything I want as long as I do the same thing across that equal sign. On the left, you can see that C is in both numerator and denominator, so they will they will reduce to 1. And likewise, the A over A and the right side will reduce to 1. And what I have left is B over A equals d over c. This is a simple little algebraic proof to show that the cross products make it such that I can just take the reciprocals. I can put b in the numerator and a in the denominator. Likewise, d in the numerator and c in the denominator. I have to do both at the same time for balance, but I can just flip those if it's convenient. And that can be very convenient when you do problem solving if your variable that you're trying to solve is in the denominator. Now, you can continue to cross multiply and pursue inverse operations as you have always done. However, this is just a nice, efficient way to problem solve faster. All right, let's take a look at another problem. Again, this is something very similar as you would see in 9th grade. I have 2 over x plus 5 equals 4. And 4 is a whole number, so we can put that over the number 1. We can use our cross-multiplying skills, so 2 times the 1 equals 4 times x plus 5. And 4 is multiplying the entire quantity, if you will, so that 4 is going to be distributed. Inverse operations, I'm going to subtract my 20 from both sides, and I get negative 18 equals 4x. When I divide both sides by 4, I get a reduced solution of negative 9 halves. And we're going to exclude any possible domain. And we can see that in this particular example, x cannot equal negative 5. All right, now let's try to apply some of these skills to something a little bit more rigorous here. I have a sum on the left side of the equal sign here in this equation, and then I have an expression over on the right. So we're going to need to either combine the two expressions on the left or try to take a more quicker route and eliminate these fractions altogether. And since I see that I have x minus 3 in both of the denominators here, the easiest approach would be to multiply the entire thing by x minus 3. And that way we're going to eliminate the fractions altogether. We just have to remember, though, that x minus 3 is going to multiply through every single term in the equation. Okay, so x minus 3 times x, I have just x times x minus 3. And when I go ahead and multiply this 6 times x minus 3, hopefully you can see that that's going to end up getting reduced out. And then on the other side, I have 2x times x minus 3. And again, we're going to see the reduced to 1 there as well. So I'm going to go ahead and start doing a little bit of the distributive property here. X times x minus 3 is x squared minus 3x. And I see my reduction here, so this simplifies to just plus 6. And on the right hand side, likewise, this x minus 3 over x minus 3, common factors, so they'll reduce to 1. So I'm just left with 2x over here. And now I'm going to get my like terms together. So I have x squared on the left minus 3x, and then I'm going to subtract the 2x from the right, so that'll give me negative 5x plus 6 equals 0. And we have a simple quadratic to solve, or sorry, to factor, given that a equals 1 here. So I'm looking for two numbers that multiply together to give positive 6, that sum to give negative 5, so that will be negative 3, negative 2. And then finally, I'm going to put both of these factors equal to 0 and solve for x. And I end up with x equals positive 3 and x equals positive 2. However, maybe you're already starting to spot a problem here. X equals positive 3 is going to cause a problem right here and here. So x equal positive 3 is going to create zeros in the denominators, or undefined terms. So we're seeing here an example where not all solutions are valid. And those that are invalid cause an undefined term, i.e. a 0 in the denominator. And the word or phrase that we describe these types of solutions is called an extraneous solution. So we call them extraneous solutions, and that it looks like extra, but we call it extraneous. In other words, hard vowel there on the A. And so in the above example, we have a true solution. Our true solution is x equals 2. However, our x equals 3 is what we would call an extraneous solution. And so that means it's invalid. It's really not a solution. And so we're going to go ahead and cross that out. Okay, let's try one more example here. Things are getting a little bit more complex, but take a look at each denominator. So I've got x plus 2, x minus 2, x plus 2 times x minus 2. So if I multiply everything through by x plus 2 times x minus 2, I should be able to eliminate all denominators. So here we go. On this first term on the left, I will have 1 times x plus 2 times x minus 2, and that's all going to be over x plus 2. My second term, I'll have 1 times x plus 2 times x minus 2, all over x minus 2. And on the other side of the equal sign, I'll have 4 times x plus 2 times x minus 2, and that'll all be over x plus 2 times x minus 2. So now we can start to reduce. On that first term, the x plus 2 over x plus 2 reduces to 1. On the next term, x minus 2 over x minus 2. And then on the right side, both these terms will reduce out to 1. So what do we have left? We have x minus 2, and I can drop these parentheses at this point because they're really not doing anything for us. We have no denominators left. Over 4, so I have 1x plus 1x is 2x. Negative 2 plus 2 reduces to 0. Inverse operations, divide both sides by 2, and I get x equals 2 as my solution. But problem, is it a solution? If I substitute x equals positive 2 up here and here, we'll have undefined terms. So x equals 2 is extraneous or invalid, as it would create a 0 in the denominator. And so x equals positive 2 is not a solution. And in this case, then, this particular equation has no solution. All right, in this video, we looked at how to solve rational equations, and we learned a new expression called extraneous solutions. Those are solutions that appear to be fine algebraically, but they create undefined terms in the equation itself, and therefore must be eliminated. Thanks for listening to this video. Hope it helps.